Hey Jeff,
Hey Matt,
so I have this problem and I was wondering if you could help me out.
no problem.
So I'm building a house and I can't figure out what heating and cooling system I should run in it.
That does sound like a real problem. Well, what exactly are you looking for in your system?
Well, first of all, I'd like it to be energy efficient and to save money so that I can afford to go to the architecture school next year.
Yes, I've heard of that. It's very, very expensive.
It is, but anyway, in addition to being energy efficient, I would also like it to be virtually maintenance free and run clean.
Clean as in no pollution?
Yeah, no pollution. But I'd also like it to be clean because I have allergies and I don't want it to be pumping crap in the air that'll make me sneeze and stuff.
I see. What else? You seem to be very demanding.
I just expect a lot out of an HVAC system. Is that too much to ask?
I guess not.
Well, I'd also like this system to get most of its energy from good old Mother Nature. You know, the free stuff.
I like free stuff.
Yeah, like snow cones after baseball games.
I like grape.
I like cherry, but grape is also my favorite.
Yummy.
Anyway, I don't want to use photovoltaics or windmills or anything because my house is pretty friggin' awesome and I don't want to screw with the party or anything. Maybe I could just do something that I could bury in the ground and forget about it. You know, like self-cleaning windows.
I had those in one of my projects. They're awesome.
Me too, but this is real. Let's get back in the game.
Well, as a matter of fact, I have just the solution for you. And believe it or not, you can bury it and forget about it.
Santa Vaca!
It's true. It's called ground coupled heat pump. But most people erroneously call it geothermal heating.
Wait, but I don't have a geyser or a volcano in my backyard. There's no way this is gonna work.
Like I said, not geothermal, it's ground coupled or ground source heat pump.
You're gonna have to explain this one to me.
No problem. Basically, it's a system that uses the Earth's natural temperature to heat or cool your home.
No way, how?
Well, between 4 to 10 feet under the Earth's surface, depending on your region, the Earth maintains a constant temperature of roughly 55 degrees all year long.
I bet it's warmer in St. George.
I doubt it. Anyway, a ground-coupled system runs water through hoses in the ground. While the water runs through the pipes, it is brought to the same temperature as the ground, which can be used to heat or cool your home, depending on the time of year. This energy is free and available 24/7, 365 days a year.
Yeah, but what am I supposed to do with 55-degree water? I like my showers at my house a lot warmer than that.
You can do a lot with it. To understand how 55 degrees can be converted into heat for your home, you first have to understand how a basic heating system works. Heaters are simply devices that move heat from one place to another. So let's say you're running a normal air-to-air heater as it gets really cold outside. Then a heater has to work harder and harder to extract heat from the air, as a result, your heating bill starts to go through the roof. A ground-coupled heat pump is basically the same exact thing, but instead of extracting heat from the frigid air outside, it takes it from the water, which has already been brought a much warmer temperature. This means that it will have to work a lot less and therefore use less energy. And when you are using less energy, it's good for the environment, and you also save money.
Money I can use for tacos and tuition.
Exactly.
What about the summer when things get really hot?
That's easy. The system just works in reverse. It's as easy and simple as that.
I'm still a little bit unclear. Do you have a diagram or something that could explain things better?
As a matter of fact, I do. Check this out.
I'm still confused. What's going on here?
Well, when the heated water comes back into the house, it meets up with a fluid called refrigerant in the heat's pump evaporator. There, the water warms up the refrigerant, or in other words, it transfers its heat from the refrigerant, and as a result, the refrigerant changes from a liquid to a gas. The gas refrigerant is then compressed with an electric compressor, which causes it to heat up. After it is heated, it moves to a condenser which then distributes the heat throughout the house.
And in the summer, it's the exact same process, but in reverse?
Yup, it's that simple.
Well, if it's so simple and relatively problem-free, why doesn't everybody do it?
For a couple of reasons. The most obvious is the system's initial cost. It costs money to bury the coils the water runs through, whereas a normal air-to-air system doesn't require the extra materials or labor.
What kind of costs are we talking about here?
Well, I'm not totally sure, but I know someone that could help us out. My friend John here knows the system pretty well, so maybe he could answer some questions.
Well, compared to cost, it really depends on the system that you choose. There are 4 different ways you can install the coils, and each has its pros and cons. Where you want to install the system usually dictates which of the systems you will use and how much more you will have to spend.
Well, my house is in the Avenues and is about 2,000 square feet. What are the 4 systems?
The most cost-effective is called an open-loop system. This takes water from a well near your home at the rate of about 5 gallons per minute, runs it through the system, and then deposits it in a stream or something. For a 2,000 square foot home, this can cost anywhere from $6,000 to $10,000.
But you'd probably have to have a lot of water to do it that way. Probably wouldn't work here.
Nope, but another relatively cheap method would be a pond loop. This would work if you had some sort of pond or lake, at least 8 feet deep near your home, and you would just run the pipes under the water. This system would cost between $9,000 and $13,000, like the one they have down at Lake Powell.
Yeah, but I don't have a pond or a lake either.
Okay, well, the most common method is dig long trenches down anywhere from 8 to 10 feet deep and run the lines horizontally. The system can cost anywhere from $11,000 to $15,000. The only thing you would need is a good chunk of land to dig the trenches. You need about 150 feet of trench for each ton of heating and cooling load. So, for a 2,000 square foot house, you would need about 400 feet of trench.
Yeah, but in the Avenues I don't have the space to do that either.
Well, the last method is to dig vertically instead of horizontally. You basically drill holes anywhere from 100 to 400 feet deep and run a 1 1/4 inch pipe down and back up to your house. For your 2,000 square foot house, you would need about 2 holes that are 350 to 400 feet deep. This would be the most expensive method because drilling costs a lot of money. You could plan on about $14,000 to $19,000.
That's not that bad.
Yeah, but bigger buildings require more holes. Rodney Pace, the director of maintenance for Murray High School, or Murray School District, told me that they had to run 350 holes at 350 feet deep to meet the needs of the new Murray High School.
Santa Vaca!
Soil conditions also matter. Some soils work better than others. The high clay content seems to work the best, while the dirt you find in St. George, it doesn't work at all.
Yeah, whatever.
Anyway, you would just need a soils engineer to come and do soils report on your property to decide what you would need to do and how deep you would have to go.
So just one question. When could I start to recoup my costs after installation?
It really depends on the variables, but a ground-coupled heat pump system has been shown to give up to a savings of 40 to 70% annually, which equals to anywhere from $400 to $1,400 a year. You would usually recoup this initial cost within the first 3 to 5 years of installation. After that, you can just pocket the cash.
Yeah, or give it to the U.
In addition to saving money over time, the systems are virtually maintenance-free, lasting anywhere from 50 to 200 years. Run quieter and don't bring in pollution from outdoor air like normal air-to-air heating systems. So your allergies will be fine. You can use this system to help you heat water for your house as well.
Wow, that's pretty awesome. The only thing I can't figure out is why everybody isn't doing this.
My guess is that they just don't know about it. So maybe we just need to spread the word.
Yeah, that's probably it.
Does that answer all your questions?
Yeah, I think so. Thanks.
Don't do that.
I got it.
Alright.
It is, but anyway, in addition to serving energy, I was doing fine. All you had to do was hold it.
To extract heat from the air. And as a result, you just moved the freaking paper and I missed it.
Oh gosh.
Yeah, but what am I supposed to do with 50 to 50 minutes? What am I supposed to
$0 to $200 a year. Whoa. Did I miss something? From 50 to 200. Oh, blast. Wow. That was bad. Yeah, I see you shaking your head. I'm like, I messed up somewhere. Okay, let's start over.
This is so dumb.
Make 12. You can do a lot with it. 200.
Crap into the air that will make me sick.
You want to try that one again?
Yeah.
Okay. That's easy. The system just works in reverse. It's really simple. That's easy. The system just works in reverse. That was really high. I better edit this thing, otherwise Matt's gonna put that one in. Reverse! There's Joni's part. Okay.
Okay, next bit. Oh man, okay.
That was a long one.
You got that.
Well, my house is in the Avenues and is about 2... This is so dumb.